Hey everyone, I'm Dhaval. I am the principal solution architect, generative AI specialist team. So in the previous session, you learned about how to get started using Amazon SageMaker and deploy and run inference for Llama 2 models. In this session, I'm going to walk you through the best practices on selecting the right instance type, the right inference option, and the right container for hosting your Llama 2 models on SageMaker. So let's dive in. So Amazon SageMaker offers you the fully managed service for end-to-end machine learning, and as part of that, Amazon SageMaker offers you the broadest range for inference options to serve any of your business use cases. With SageMaker, you can deploy your model endpoint behind an inference endpoint using a RESTful API and invoke the endpoint with a payload via RESTful API call and get the inference response in a streaming fashion too. Now, you can use the real-time inference endpoint for ultra-low latency applications or ultra-low latency predictions, which we are going to dive into the details today in this session. Or you can use batch transforms for offline inferencing when you have very large data sets for running the inference. Now, if your inference requires large payload processing like image file or video predictions, and if the inference is likely to run long time, then you can use SageMaker's asynchronous inference option. Now, you either can deploy a single model behind an inference endpoint, or you can deploy thousands of models behind an endpoint. You can also jointly deploy the pre-processing and post-processing steps as a serial inference pipeline on SageMaker. At the infrastructure layer, you have choice of deploying the models on CPUs or GPUs or AWS Silicon like AWS Inferentia 2 or Trainium, or go entirely serverless. So with SageMaker, you not only get the right model hosting option for your business use case, but also the best performance with the lowest cost. So in this session, I'm going to walk you through how to select the inference option for hosting the Llama 2 models for your ultra low latency applications, which in this case it's going to be the real-time inference endpoint for SageMaker, and then I'm gonna walk you through how to select the instance type and then the right container for running the Llama 2 models on SageMaker. So let's dive in. So the first is the instance type selection. Now, selecting an instance type for is based on the few factors. The first and very important factor is the runtime memory, and that is dependent on the model size and the sequence length, which is basically the length of your inference request. And then it is also dependent on the amount of the concurrent request that you get or you want to process at any point of time while you're running the inference. That means the desired concurrency, or we say it as batch size, which means batching multiple inference requests and processing at the same time to get the best price performance. And the third point is the response time of your applications. The response time is not only just dependent on the size of your payload, which in this case for the large language model is input size and the output size, which is input tokens and output tokens, but also dependent on the hardware, which basically drives the response time SLAs. So the response time SLAs for your business use case is a primary driver in selecting the right instance type and the right hardware. Now, we recommend using instances with A10G or A100 or H100, which basically is G5 or P4 or P5 instance family, and the performance is much greater as compared to the older T-series NVIDIA GPUs. Now, you should select an instance type from these recommended instance types that I just mentioned, which has sufficient aggregate memory across all of the GPUs or across all of the ML accelerator devices for both loading the model and making requests at the run time to achieve the concurrency level that you're looking to. And so I'm going to walk you through quickly. We have got a good example on using the Llama 2 13 billion model. And I'm going to walk you through quickly how to calculate the runtime memory required to load the 13 billion model, and then actually show you the step-by-step all these recommendations that we just walked through. All right, so you have fine-tuned, or either you want to deploy an open source Llama 2 13 billion model. Let's put that into production for the inference. All right, so the first thing that you do is to calculate the amount of memory needed to load the 13 billion model, and which is dependent on primarily the model size. And the model size is primarily dependent on the number of parameters and the size for each parameter. In this case, we're talking about 13 billion parameters, and each parameter takes 2 bytes in this case. Now, these I've shown FP16 here, and that means that it's a quantized model size to use 2 bytes per model parameter. Now, quantization is a technique to compress the model size by converting high precision floating point representation to a lower precision like FP16 or BF16 or even int4 or int8. And there are other optimization techniques that will reduce the model size without much compromising the accuracy part of it. Now, if you use FP32 data type, it will double the size. So for now, we'll just use FP16 data type version of the model that gives us around 26 gigabyte of the size for loading 1 copy of the model into the memory. Now, in the autoregressive decoding process, all of the input tokens to the LLM produce their attention key value tensors. And these tensors are kept in accelerator's memory to generate next tokens. These cached key and value tensors are often called as KV cache. That also occupies about 4 to 13 gigabytes of additional memory, which depends on the input and output tokens and the amount of concurrency that you wish to handle for your application. So the total memory required to load a single instance for Llama 2 13 billion for FP16 comes out to be approximately 46 gigabyte. Now, how did we calculate the KV cache size? Let's dive in. So the KV cache, here's the formula for calculating the KV cache in order to calculate the total runtime to run the inference. The KV cache is first counted based on the token, per token basis, and it's basically 2 times the data type, which here in this case we are using 2 bytes or an FP16 data type, and the number of hidden layers for that model, and the hidden size. The number of layer represents the number of transformer blocks in the model. And the hidden size represents the dimension of the attention block. So let me show you how to get the values for the number of hidden layers and the hidden size that is required to calculate the KV cache size as per this formula. So I'm in the Hugging Face website, and I've pulled in the metadata for Llama 2 13 billion with FP16 quantized model, and the basic file, the metadata file, which is called as config.json in this case, will give you a lot of information about the model architecture, including the number of hidden layers and the hidden size, which in this case I'm going to highlight. Hidden size in this case is 5120. And the number of hidden layers and the hidden heads are, attention heads and the hidden layers is 40. So we are going to use this values and in calculating the KV cache per token for Llama 2 13 billion as per the formula that I showed. And then we'll calculate how much aggregate memory you require in order to process 4 concurrent requests at any point of time per instance. So let's let's use these values that we saw in the config.json for the number of hidden layers and the hidden size, which is 40 and 5 and 2 respectively. So you get the KV cache size per token to be this value that I'm showing on your screen. And then you kind of go back to the inference request that you're going to send, and you're going to get an idea of how many input tokens and the output tokens is probably going to generate, which in this case, we are going to assume 4096 tokens per inference request, which comes out to be 3.36 gigabytes required in terms of the KV cache. You just have to reserve that much in order to serve one request with 4096 tokens in it. Now, if you want to enhance the performance in terms of the throughput and also the concurrency, you might want to handle more than one request concurrently. In this case, let's just assume since we have more memory in the GPU, probably we should start with handling 4 concurrent requests at the same time, which comes to be almost 13 gig required just for KV cache and the autoregressive process, in addition to the model size itself. All right, so now that you know the memory required to load the model and have an estimate of the runtime memory required per token, we can figure out the instance type to use. So we recommend you have an understanding of the max sequence length you will be operating with, which is prompt tokens and the generated tokens. Alternatively, you can select an instance type and calculate a max batch size estimate based on the available memory. So for our Llama 2 13 billion model, we need a minimum of 26 gigabytes of the memory, For our Llama 2 13 billion model, we need a minimum of 46 gigabytes of memory. And so let's consider 2 instance types. G5 12x large, which has 4 NVIDIA A10 GPUs with an aggregated memory of 96 gigabytes, which can very well fit the 46 gigabyte overall memory requirement for our model. Or you can go higher, which is G5 40XL, and load multiple copies of the model, and can also increase the concurrency to accommodate more number of concurrent requests. So this would provide enough memory for running 4 inference requests at currently 4 requests currently with our current requirements. And let's go with G5 12XL to start with. All right, so now you selected, so you have the inference running for Llama 2 13 billion, and you need approximately 46 gigabytes and we select G5 12XL, which has 4 A10G NVIDIA GPUs with an aggregated memory of 96 gigabytes. You can easily fit the 46 gig model into the 96 gig of the host memory or the GPU memory. But let's take a look at how it looks like. So in a G5 12XL, you have 4 NVIDIA A10G devices with each with 24 gig. Now you can't possibly fit a 46 gigabyte into any one of these devices entirely. So there's no way you'll be able to fit this model on a single device, even if you select a larger instance with A100 or even H100s. Possibly H100s you may be able to fit in, but not necessarily with A100 or A10Gs. So what do we do here? Because you're going to get CUDA out of memory here. So what do we do here? Well, you will need to shard the model into at least 2 shards so that you can fit the model into 2 GPU devices. However, there are still 2 GPU devices left, idle, which we can utilize. Now you can increase the shards to 4 and can fit more inference requests in terms of the concurrency. And so remember, the sequence length and the number of concurrent requests plays a very critical role in the KV cache size and the overall runtime memory requirements for loading the model and selecting the right instance type to achieve your concurrency levels and the performance in terms of response time SLAs. All right, so we are going to use G512XL, and I'm going to walk you through real quick on how do we select the inference option and the inference instance type and the container. Now, before that, just quick note about what is the right container to use to deploy your Llama 2 model or any other foundation model on SageMaker. We recommend you use large model inference container, which is pre-built container for fully compatible with SageMaker, which is with high performance out of the box features for you to use it to increase the throughput and reduce response times and overall get the best price performance. And the large model inference container supports different types of distributed inference options, including tensor parallel and pipeline parallel, and various different optimizing techniques to increase the performance and lower the cost. It also supports different open source frameworks, including Hugging Face, the AWS Neuron library, which basically is required for running the inference on AWS silicon chips, including Inferentia and Training, and open source DeepSpeed, open source frameworks like VLLM and TensorRT LLM. We also have different optimization techniques to speed up the loading of the models, compilation of these models to improve the response times, low code, no code way to configure all these different types of performance options, including the quantization, are all built in, and we offer them as out-of-the-box features with almost zero code setup, which we're going to see in this in the code that I'm going to show you. So let's go into the code and see how we do it. All right, so this example is basically to serve Llama 2 13 billion on SageMaker using large model inference container. So let's walk through. So here we create the SageMaker session and use the board of 3 client, Python board of 3 client in this case, and create the SageMaker SageMaker client and SageMaker runtime client. And then basically what we are taking up the use case where you're deploying this model for the open-ended generation like chatbots. And the chatbots types of use case generally have a small input size with a small generated token, text, or it could also generate large number of tokens as well. So you never know that how much output it's going to generate. So we call it as open-ended generation. So if you're looking to deploy Llama 2 model for chatbot type of use cases, here is the best practice of selecting the right instance type and the right container for running the real-time ultra-low latency applications. All right, so I'm going to show you a demo of deploying the Llama 2 13 billion model on SageMaker with a ultra-low latency application using real-time inference endpoint on SageMaker, and then I'll show you how to configure the large model inference container for your use case, and then how we are able to fit in the model and basically the KV cache and all of those calculations that I've showed you earlier. How does that work in the large model inference container, and how does it help reduce a lot of heavy lifting on your end as well? So I'm going to walk you through all those options. So let's get started. So this example shows you the deployment of Llama 2 13 billion on SageMaker using large model inference container for real-time use cases. We're going to spin up a real-time inference endpoint with the model loaded. So we first create a SageMaker session with an Emboto 3 client for SageMaker and SageMaker runtime to invoke the inference endpoint. And basically, the use case here is an open-ended generation, text generation use case for chatbots. Generally, chatbots have to deal with a smaller user input size and possibly a variable-sized output tokens. And so for the chatbot type of open-ended generation, we recommend using large model inference container and specific backend, which is called as VLLM. Now, VLLM is a fast and easy open source framework for serving large language models at scale with high performance, which is fully integrated and offered as an out-of-the-box backend as a feature as part of the large model inference container on SageMaker. So you can so the first thing, in order to configure the model for deploying into the inference endpoint, is to retrieve the container image URI that we are going to use. In this case, it's going to be large model inference container. You can see here the version is the latest version that we just released, which is 0.27. And you can configure a lot of performance tunables, including the backend, which in this case we are going to use as VLLM. You can configure all of these parameters as part of the environment variable. In this case, the one of the important environment variable is the model ID, which is the model that you want to deploy, and which is the model ID in the Hugging Face. And so we just simply copy paste the Hugging Face model ID from here to this, which you can see the same value here. In earlier section, we saw that you will not be able to fit the entire model into one of the GPUs available in the G5 12x large, and that you have to shard your model at least 4 shards, or at least 2 shards, and then you can extend it to 4 shards. In this case, we are going to shard our model into 4 shards, and that's what it represents here by setting the value for tensor parallel degree to 4. All right, now here's another parameter that you should use, which is called as continuous batching, which will increase your throughput. And we are going to dive into these optimization techniques in the next session as well. But just an overview, rolling batch is also called as continuous batch, which is a great performance throughput optimization technique to increase the concurrency and get best out of in terms of the price performance. So I would highly recommend you use rolling batch using the VLLM open source for open-ended text generation. Now, there are a couple of other performance parameters that you can set, which is the batch size for the continuous batching or the rolling batching, which in this case we have set it to 32 because we have a little bit of more memory left in the host in terms of the GPU memory, and so we can leverage that by increasing the batch size to 32, so that we can squeeze the maximum out of the compute and the memory that we have in that host, and you can get the best price performance. And then the D type is the quantization level, which in this case is FP16, which basically takes 2 bytes per parameter. So, all right, so after you set all these parameters, the next step is to create a model object, which is SageMaker model object with the model name and the container name with the image that we set, which is a LMI container with version 0.27, with the environment variable we just went through, and then you create the model. And then the next step is to create the inference endpoint config, which basically allows you to specify the instance type, which in this case is G512XL You can also mention the initial instance count, which is 1. You can also auto scale the inference endpoint to multiple instances. You can configure the scaling policy on the basis of which it will scale out, and you can also scale in, and so on and so forth. Now, very important part of the of this configuration is the routing strategy, the way how the inference requests gets routed to the individual instances behind the auto scaling fleet is extremely important for in terms of the performance, wherein using the least outstanding request policy in this case will allow almost even distribution of your inference requests across the instance types. So I would highly recommend you use least outstanding request policy for routing strategy for running large language model inference. All right, and then let's go to the next step, which is creating an endpoint using the model object and the endpoint config object we created. And so the here is the create endpoint step, which basically you have to wait a few minutes before the endpoint comes up, and then once the endpoint comes up, you can invoke the endpoint with the sample prompt. And here is the format of the prompt, which is a JSON format. Basically has inputs as the key, and you can send the prompt as part of the input attribute, and then along with the input, you also can send additional hyperparameters that you want the container to use in order to generate the output text. In this case, we'll use there's an additional parameter called parameters, where you can send additional hyperparameters like top P temperature, max new tokens, do sample, and you can also use different types of sampling techniques, and you can get different types of outputs depending on your business use case. So we are going to use a sample prompt. In this case is a very small prompt with the parameter of max new tokens with 100 and sampling as false, and then you just simply invoke the endpoint using invoke_endpoint using boto3, and you get the output. Right. So this was I just walk you through the typical deployment steps for deploying the Llama 2 13 billion model for real-time use case using real-time inference endpoint. And I will walk you through the best practices on selecting the right instance type and the right inference container to use. Now, we also have a low-code, no-code option for you to leverage as part of the large model inference container, where you really do not need to worry about configuring the rolling batch size or continuous batching size, configuring the tensor parallel degree, or configuring the number of shards, and so on and so forth. What we are offering from the version of from 0.27.0 version of LMI container is a no-code, low-code option, where we will do the selection of the best performance tunables based on the instance type that you specify and the Hugging Face model ID that you specify in the environment variables, and we do the heavy lifting of figuring out the right parameters. So let's walk you through how can you use that feature. So the only thing we require in order to use this feature is to give us the HF_model_ID, which is the Hugging Face model identifier, as part of the environment variable when you create a SageMaker model object. And once you give that, that's it. You do not need to configure any kind of other additional environment variables, or you do not need to set any other parameters. We will automatically figure out how many shards you can fit into the given instance type, and for that specific model ID that you've specified. And then we will do our best to give you the highly performant tunable configuration. So that's about it. You just give us the Hugging Face model ID, and then you create a model object, and then you give us the type of the instance, which in this case is G5 12x large, and you spin up the endpoint. Here in this case, I'm using SageMaker Python SDK just for a change. You can also use Boto 3 as I was using in the earlier section. And so here in this case, predictor represents the predictor object for running the inference for the real-time inference with all the configuration details, including the instance type and the model and the container and additional details. So basically, model.deploy is going to deploy your model, and then you run the prediction by invoking the endpoint and get the output. That's about it. Predictor.predict will invoke the endpoint, and you get the output text. Right? You don't need to configure anything else except Hugging Face model ID, and we do the heavy lifting. And then you ultimately clean up the environment by deleting the endpoints and endpoint config and the model object. Don't forget that. It's very important. All right. So overall, in summary, we saw how to select the right inference option, the right instance type, and the right container for running large language models, specifically in this case for Llama 2 models on SageMaker. Here are some of the resources for you. Here's the sample notebook link and the large model inference container documentation, where you can find plethora of information, including additional performance tunables and additional best practices on selecting the right instance type. I hope this session was useful. I'll see you in my next video. Thank you very much.